Sciences classroom. Today is the 9th of July 2020. My name is Nonkululeko Matondo and I am your teacher for Physical Sciences grade 11. I hope that you guys are all good and having a great day. Today we're going to be doing electric circuits and Ohm's law. I hope that everybody had fun doing electromagnetism, which we were doing for the past 3 days and up until yesterday when we did the Faraday's law of electromagnetism. I hope that everybody is understanding and now knows basically the theory behind it. Reminding you guys again that in this term, in this year, um, 2020, um, there has been an adjustment to the caps, to the caps, to the caps ATPs, and for this module for electromagnetism, what they have removed the calculations with regards to everything that has to do with electromagnetism. So which means that we won't be doing calculations for electromagnetism. And that is why we've been doing a whole lot of theory and skipping the Coulomb's law calculations. We also now skip the Faraday's laws calculations as well, because those are not going to be part of your examination. The most important part is for us to cover the things that you need for you to pass grade 11 in 2020. Nonetheless, another thing you guys have to know is that you're only going to have one paper this year, unlike all the other years where you had paper one and paper two. If you remember in grade 10, this year there's only going to be one paper. And another thing that you guys also have to know is that for this year, chemical systems have been completely removed from your examination, so you do not have to do that. So I think you guys have a great chance of getting like very great marks this year, especially with the situation and all the papers that have been adjusted and all of that. The paper is going to count out of 150, so which means that it's going to be 80 for physics and 70 for chemical for chemistry. So if you guys understand everything that you're doing and everything that we've been doing together in this classroom, I do not think that you guys are going to suffer this year. Okay. Another important thing that you guys also have to note is that basically the textbook that I'm using here, I'm using the Siavula textbook, and I'm also using the Oxford Successful textbook. If you've been with these classes since the previous term, you'll remember that I always work with the Oxford Successful textbook, as it explains things more in detail. But they all do, all the textbook do, as long as they are CAPS certified textbooks, then they are good for you guys to study from and read from. But if you feel like you still need some textbooks, external textbooks for your work, or not only for physical sciences, you guys can download Snaplify. Snaplify is an application. You can get it on your PC, you can get it on your phone. It's absolutely free. All textbooks are free, and I'm letting you guys know this because I understand that sometimes limited resources stop you from getting to certain understanding of the work that you do. So you can get yourself Snaplify. The textbooks are free until the 31st of December 2020. So if you need some textbook, you can get them. You can also view them online. That's a great thing about Snaplify. So if you are trying to figure out, other textbooks or other means of getting resources, you can get yourself Snaplify. I am Nonkululeko Madondo, and I am your physical sciences grade 11 teacher. So, just a few things that I gave you guys homework for, and I hope that you guys did manage to do it. Is this last question? Remember, we did most of the question that have to do with we did most of the questions that has to do with Faraday's law of electromagnetic induction, but I left number 5 out, and I asked you guys to go and do number 5 at home as homework, because it's very important, guys, that I give you guys something that you can do on your own. Why is that? So that you guys can understand what you understand and what you do not understand. The most important part is for you guys to know what you're doing. And for that to happen, you need to try doing things on your own outside this classroom. So that's why I make sure that even if it's one problem or two problem, you guys always get homework. And I hope that you did this homework and now you understand what you understand. Okay. So it says here on this figure 5 shows a magnet being pushed towards a loop. Okay, so you know what that means, right? It's getting pushed towards a loop. It means obviously electricity is going to be induced. All right, so here they say the magnet is being pushed towards the loop. Okay, so the question starts here on 5.1. It says if the flux linkage increases, is the flux linkage increasing, staying the same, or is it decreasing? Huh? Is the flux linkage increasing, staying the same, or decreasing? It's likely to increase, isn't it? Because it's moving. Remember, the most important part is for the magnet to move towards the loop, the circuit, the solenoid, etc. So in this case, it is moving. So flux linkage will be increasing, okay? So it will start to increase because electricity is starting to be induced, okay? So 5.2, they ask that a current, they say a current is induced in the loop, right? That's the whole point of why the magnet is moving into the loop as per Faraday's law of induction. So what they want to know is, the first one they ask is, give the direction through the loop of the magnetic field of the induced current, okay? Give the direction through the loop of the magnetic field of the induced current, okay? So what it says is, say it's to the right of the diagram, okay? So if this is a diagram here, it's to the right. So this is direction through the loop of the magnetic field of the induced current. It's going to be to the right of the diagram, okay? So 5.2.2, it says, describe the effect of the magnetic field of the induced current on the resultant flux linkage with the loop. Describe the effect of the magnetic field of the induced current. Remember, the magnetic field is a procedure of inducing current on the resultant flux linkage with the loop, okay? And that they say the magnetic field of the induced current reduces the resultant flux linkage with the loop so it is less than the flux linkage of the magnet alone, okay? Are we together? I'm going to repeat that the magnetic field of the induced current reduces the resultant flux linkage with the loop so that it is less than the flux linkage of the magnet alone, okay? So 5.2.3, it says, state the direction of the force that the magnetic field of the induced current exerts on the magnet. But remember what we said before. We said that it always has to oppose. So it's a repulsion force, okay? So it's to the left. Remember, they always have to oppose each other in order for them to induce the current. Okay. Do you guys understand? I'm just reminding you guys again that as I move along through a lesson, you guys are allowed to drop me a chat of where you don't understand so that I can go back and try and explain it to you. So if you do have a problem while I'm teaching, just send me a chat, drop me a chat quickly, and I'll make sure that I get back to you and try and explain where you are getting stuck, okay? So that marks the end of electromagnetism that we've been doing. And now, just a small summary of the electromagnetism, that things that you guys should carry through, things that you guys should be knowing by now, okay? Is that electromagnetism is a study of the properties and relationship between electric current and magnetism, okay? So there's a relationship between electric currents and magnetism. So a current carrying conductor will produce a magnetic field around the conductor. Current carrying conductor will produce a magnetic field around the conductor. So the direction of the magnetic field is found by using the right hand rule. Remember the right hand rule? What it states is that if your thumb points to the direction of the current flow, then your coiled hands will point to the direction of the magnetic field. So those are very important things that you guys should remember, okay? So electromagnets are temporary magnets formed by current carrying conductors, okay? Those are electromagnets. They are temporary magnets formed by current carrying conductors, okay? So the magnetic field through a surface is the product of the component of the magnetic field normal to the surface and the surface area, okay? So you remember here, this is what we spoke about as well. So the magnetic field through the surface is the product component. Remember the product component is the fact that um, it must be a, um, a value that's perpendicular to the surface, okay? And that becomes the angle component because if it's, for example, at an angle, we're not going to take the parallel component, which is sine theta in this case. We will take the perpendicular component, which is the cos theta, okay? If you remember from the lesson that we had yesterday. And then another thing that we need to know is that the electromagnetic induction occurs when a changing magnetic field induces a voltage in a current carrying conductor. The electromagnetic induction occurs when a changing magnetic field induces a voltage in a current carrying conductor. Okay? And then last but not least is that the magnitude of the induced EMF is given by Faraday's law of electromagnetic induction, which states that the EMF is equals to the change in flux, the rate of change of flux. Okay? Okay. I hope that we are good to go now and you have finally understood the laws of electromagnetism. So now we're moving on. We're going to be talking about the electric circuit. So today it's all about the electric circuit and the Ohm's law, basically. So that's what our class is about today. So we're going to do some bit of revision of electric circuit. Okay. So when you think of an electric circuit, what is an electric circuit? You think probably that you know that it's something to do with um, wires connected to each other to a source in order for the light bulb to shine. I think to operate, right? That's how we used to do, especially in grade 10. But now, getting to that revision, what is an electric circuit? By scientific definition, it's a continuous conducting path along which electric charge can flow. Electric charges can flow. Okay? So it's a continuous conducting path along which electric charges can flow. But obviously, this pathway, you cannot just make a pathway from nothing. There's certain components that are required for this pathway of electric charges needs to be provided for, okay? So the number one component that we need an energy source, okay? An energy source that can transfer electrical energy into the circuit, okay? So basically in this case, maybe it can be batteries, right? So we can use batteries in this case. It's an energy source. It what brings the energy into the circuit, okay? Number two is conducting leads. They have, okay, conducting leads, it's a conductor basically, which basically means the wires, the conductor. This is the one that's gonna take, that's gonna be the travel mechanism of the electric charge. Okay, that's basically what's going to make the pathway for the electric charge. It is the conducting leads, or we can have it as conductors. Okay, they have a very low resistance. Okay, and then we also have the load. The load, this is where the transfer of energy out of the circuit through resistance is, right? So this could be light bulb, components such as motors, you know. So basically, here is an example of something that you can even do at home, a simple electric circuit. This is your energy source, your batteries, and these are your leads, your little conductor, and this is your load. Your load is where your electric charge is moving towards, or what its job basically in this case is to light up the light bulb. Okay, so this is a load. That must be a load. Okay, and the load is the energy out of the circuit through resistors. So there should be resistance that allows for this to happen. Okay, I hope that you understand basically now what is an electric circuit and the components of an electric circuit. So this is the simplest electric circuit that you can find. Okay, so components of electric circuit, these are some of the stuff that you need to know, that you will find, especially when you have to, or you are required to draw an electric circuit. Okay, this is a sign for a battery. If you remember, a battery is this thing. This is your energy source basically. Your energy source will always be written like this, be it a battery or DC, anything. This is how it will look like. Connecting leads, this is your conductor. Remember, I spoke about connecting leads or a conductor being the pathway in which the electric charge will take, okay? They act as a pathway, basically, okay? So they'll be indicated by a straight line. And then connecting leads, if, for example, the leads, you have two conductors joined together, this will show by a line in the middle that these are two wires that have been joined together. So connecting leads that are joined, it's these ones. So basically here, these, for example, you'll need to know this if it's a series conductor, okay? So this will be, for example, um, 1 and 2, okay? They are in series. But sometimes you find that your leads are connected in parallel. So they cannot be joined together. They will show by this that these two lines are not connected to each other, okay? And then now we have the resistor, which is this one here, which is our little load over here. This will be our resistance, which is what we're going to speak about more as we move into the chapter. And then you have a variable resistor. What is a variable resistor? A variable resistor is a resistor that has, for example, you can tune it, you can adjust it. For example, you can increase or decrease the resistance using a certain mechanism that you'll find on that resistor. So if you want 10 ohms, then you can move it to 10 ohms. If you want 5, you can move it to 5. So that's why they call it a variable resistor. Okay. And then we have the light bulb. A light bulb basically is our result. Our result that we can use, it's a load on our electric circuit at the end, whether it lights or doesn't light. So if you use it in an experiment, if your light bulb doesn't switch on when you've connected everything, your components of your electric circuit, then it would mean that there is no electric current flowing. So there is no electric charge. But if it lights up, it means that you have connected your stuff properly and it is light. It is working, okay? So there is electric charge that's flowing in your circuit. And then we have a switch open. So this is an open switch. What does this mean, guys? An open switch means that if you have a circuit and it shows a sign like this, it means that there's no current flowing because your circuit is open. And a circuit can only flow if current can only flow if your circuit is closed, okay? So if it's open, in this case, it means that your current will be zero. There won't be any current flowing in this part of your circuit, okay? Okay, I hope that now you understand more of these symbols and what each of them means, okay? Now, moving on, electric circuit quantities, okay? We've spoken about the components of an electric circuit, but now there is quantities. There's those quantities that you cannot actually see operating. There's the physical and the scientific ones, okay? So electrical circuits are an important study in understanding the technology using electricity. Electricity is a basic need, and it allows a possibility of many things and many uses at home and at the workplace, okay, or everywhere. So it's only sometimes when there's no electricity where you realize that there's so many things that we need electricity for. Power failures limit a lot of operations and uses required from electricity. For example, even bathing or drinking tea, those things they all require energy, electricity, because you need to switch on the kettle for you to do that. Okay. So there are three fundamental quantities of electric circuits, and those are basically their parameters. It's current, it's voltage, and resistance. Okay. So these are the three things that will be a result of an active electric circuit. Okay. So number one, we've got the current, which will be indicated by an I. The current is the rate of flow of charge through the circuit. So there'll always be current. That basically when we make an electric circuit, we want current to flow in the circuit. Okay. And then number two, we have the voltage, which is indicated by a V, is the amount of energy per unit charge needed to move between 2 points in a circuit. Basically, this is the potential difference. That's why they said needed to move between 2 points in a circuit. Okay. The number three, we've got the resistance. This is the measure of how hard it is to push current through a circuit element. So the relationship between these three quantities can be defined through Ohm's law. Do you guys remember Ohm's law? So this is our definition of what Ohm's law is. You can even draw it in a triangle if you'd like, to never forget it. Ohm's law, it states that the amount of electric current through a metal conductor at a constant temperature in a circuit is proportional to the voltage across the conductor and can be described by this equation that say current is equals to voltage divided by resistance. Okay, I hope we're still together. So basically, the amount of electric charge through a metal conductor at a constant temperature in a circuit is proportional to the voltage across the conductor. And this is how it is described. So in this case, I is the current through the conductor, and then voltage, V is the voltage across the conductor. So if you put your voltmeter across the conductor, then you will get a voltage reading there, okay? So the voltage is a V, with V is the voltage across the conductor, and R is the resistance of the conductor. In other words, at a constant temperature, the resistance of the conductor is constant, independent of the voltage applied across it or the current passed through it. Okay? Now we're moving on to the Ohm's law. It says that the Ohm's law tells us that if a conductor is at a constant temperature, current flowing through the conductor is directly proportional to the voltage across it. So this means that resistance is indirectly proportional to the current. If you check from this equation here, you see, it's inversely proportional to the current flow. That is If the resistance is increased, then less current will flow, and it acts basically as a limiting agent of current flow. Okay? So I just want us to check something out on the Siyavula textbook. Okay, here it is. Yeah, so here, this is the statement that I just spoke about, that Ohms Law tells us if the conductor is at constant speed, the current flow through the conductor is directly proportional to the voltage across it. This means that if we plot voltage on the x-axis, which is this part here of the graph, and current on the y-axis of the graph, we will get a straight line because they are proportional to each other. So which means if they are proportional, so basically this is what you'll have. This is the voltage and this is the current, okay? So which means this part here is a resistance. So the gradient of the straight line graph is related to the resistance of the conductor. Okay, so V over R is equals to 1 over R. Okay, so this can be rearranged in terms of the constant resistance. So resistance will be equals to voltage over current. Okay, so there's an experiment, because I see that it's been done in most of the textbooks, but we can read through it because there's also questions that follow up from that. But I think it's very important that we should know what is going on. Okay, let me just to the other textbooks, the Oxford Successful textbook. I was really interested in this experiment because it's very informative. Okay, I don't want us to do this one here. I like the one on the Siyavula textbook. So when you want to investigate the relationship between current, voltage, and resistance. So basically, we're going to treat this like a virtual experiment. So it says here, you will investigate the relationship between current, voltage, and resistance over a range of voltages and currents for a resistor and a light bulb, okay? So the hypothesis is the ratio V over I for a component remains constant, provided the temperature remains constant. So basically what they used here, they used an energy source such as two 1.5 batteries. They used a torch bulb. They used resistor, an ammeter. What is an ammeter? An ammeter is a measuring device that is used to calculate current flow. And a voltmeter is a measuring device used to calculate the voltage in an electric circuit. And then we've got a rheostat. A rheostat is what measures resistance in a circuit. And then we've got a switch, and we've got our connecting leads, which can also be the conductors in the circuit, okay? So these will be our connecting leads. This is our battery, this is our resistance, and this is our ammeter and voltmeter, and this is our switch, okay? This is the switch there. Okay, so what basically you do, things that are independent variables, we've got the current in resistor, dependent variable voltage across the resistor, and fixed variable is a temperature. Okay, so the method that they used here, they say you connect the circuit with the resistor between X and Y, as shown in the circuit diagram. The voltmeter measures the voltage across the resistor, and the ammeter measures the current through it. Okay. Okay. So that's our first step. Okay. So basically, this is the circuit now placed in equivalent form. Okay. So this is a circuit diagram of the apparatus setup. So whenever you set up your apparatus, whenever you set up your ammeter, you must always make sure that when you set up your circuit, you must make sure that your ammeter is in series to the resistance and your voltmeters is parallel to your resistor. Okay, so this is your normal setup. That's your switch. Remember, this is your energy source, this is your battery, and this is your load. Remember all these things, right? So, number two, you take current and voltmeter readings and record your results in a table similar to this one. So to obtain a new pair of reading, you adjust the rheostat. Oh, our rheostat, sorry guys, it doesn't make this one is the resistor, okay? So basically it's adjustable. It means that it's a variable resistor. To change the current in the resistor, you can adjust the rheostat basically to get the current that you need. So basically, that's your variable. That's the one that you can change, the controlled variable. So you switch off the circuit between the readings so as to allow the resistor to remain at room temperature. So you need to obtain at least 7 pairs of readings. So basically, you will have 7 readings. And how did you get your readings? Because you were adjusting your variable resistance to get certain amount of so all of them, the ammeter and the resistance are all placed at the same time. So when you adjust your rheostat, you'll get a certain voltage reading and you'll get a certain current reading. Okay? So you obtain at least 7 pairs. Calculate the ratio for each pair and draw a graph of V versus I of the pair of readings. Then this is what you're going to get, right? So the table of results for your resistor and the table of results for your light bulb, okay? This is what you get. So every time you adjusted the rheostat, for example, you adjust it up until it gives you a current, until your ammeter gives you a current of 0.05, and then you record your 0.05, and then you check what's on your voltmeter. Then you write what's on your voltmeter. Then you adjust the rheostat again, and then you check your current increasing or decreasing. When it gets to 0.1, you stop and you check what's on your voltmeter, and that's what you get. So basically, that's how this experiment was done. It's very, very interesting, okay? And then you record them, and then you multiply them together, which is your ratio. You're going to say V divided by I, and you get your resistance. And then you do the same thing for your torch bulb, and this is the graph that you get. So you see these graphs are not the same. For the one with the resistor, it's a straight line graph, but for this one, it's a curved graph. So now here are the questions that I want us just to partake in. It says here, refer to the graph of the voltage across the resistor versus current, which is figure 4, and answer the following questions about the resistor or piece of resistance wire. So it says on number 1, describe the shape of the graph. Okay, so we can see clearly that this is a straight line graph. So state the relationship between voltage across the resistor, and current in the resistor. State the relationship between the voltage across the resistor and the current in resistor. So what you can say is that they are proportional to each other. So what does proportional mean? It means that when as the current increases, so does the voltage increase as well. Okay, so state whether the ratio VI is constant. In this case, it is constant because it's a straight line. Okay, so it says here the resistor R of the resistor is calculated with the equation. What conclusion can you draw about the resistance of the resistor over the range of current values? Okay, what conclusion can you draw about the resistance of the resistor over the range values of current? Okay, all we know for now is that as the voltage increases, as the current increases, the voltage decreases. Okay, but let's just check our good answers right there. Okay, yes. the resistance remains constant over the range of values of current. Okay. Yes. So basically, that is the answer for what we were looking for. And then moving on to number two. So number two says refer to. Now we are on this graph here. So they ask here, 2.1, describe the shape of the graph. So the shape of the graph is curved. Okay. So they say now compare the size of the ratio of VI for the light bulb when burning dimly and when burning brightly. Okay. So let's check that one out. What it says there. It says that the graph passes through the origin and is curved. Okay, it's not a straight graph. So the ratio VI is larger when the bulb is burning brightly than when it's dim. Okay, so the ratio is very high when, which means when the resistance is great, because this ratio is equals to resistance. So the when the resistance increases is when the bulb is burning brightly, but when it's dim, then it's very low. Okay. And then here they say write the words that make the following sentence correct. The resistance of the bulb increases, stays the same, or decreases as the current through it increases. Remember, guys, it is indirectly proportional. So if the resistance of the bulb increases, it means that the if the resistance of the light bulb decreases as the current through it increases. That's what it means, right? So do you accept or reject the hypothesis for this experiment with regard to the light bulb? Let's see that one. And it's a reject. The voltage across the light bulb is not proportional to the current in it. Hope you guys all enjoyed. And thank you guys so much for a beautiful class. This is your grade 11 physical sciences class. My name is Nonkululeko Madondo. And thank you so much for joining me in this class today. If you have any queries or questions that you'd like to know, you can get me on t32tndlovu@gmail.com, and you can ask any question that you'd like to know. But for me, it's goodbye.